Hello students. In the previous video we have studied about what valence shell electron pair repulsion theory, and we have seen in that that yes, it could say about the geometry and the shape, but yes, it could not theoretically explain why it is happening and why these shapes are coming properly or theoretically. Okay, so these all things we will be coming to know by what valence bond theory and molecular orbital theory. Okay, so here we see what Hitler and London, okay, they gave this first, okay, and then it was improved, or it was further given by whom? Pauling and other scientists. Okay, actually this valence bond theory is based on what? Atomic orbital, electronic configuration, overlap criteria of atomic orbitals, and principal variation, as well as what? Superposition. Okay, so these all what I have said is what it is dealt with now with what? The quantum mechanics. Okay, and so here we will be dealing with what? The quantum mechanics, in order to know why this shape or the geometry is coming, okay, theoretically. Okay, so now this valence bond theory, it discusses only the qualitative and the non-mathematical treatments. Okay, when we will be studying about this valence bond theory, many things will come in our brain that yes, we are just by hearting it, we are not doing anything. What to do? We have to only keep in mind that this is coming, but this is not true, beta, because this has been calculated and formulated mathematically, okay, and then the result has came. So theoretically it is able to explain about the shape and the geometry of the compound. Now let us understand valence bond theory. In short, we can say VBT also, okay, with the help of hydrogen molecule. Okay, first you can see over here hydrogen and hydrogen, two items of what? Hydrogen. Okay, we have taken. Okay, now what happens here? The nucleus of hydrogen A is written as Na and electron is written as small ea. Okay, like that hydrogen B, okay, the second hydrogen atom, nucleus is written as what? Nb, and electron is written as Ab. Okay, now see what happens. Here first these two hydrogen are quite far apart. Okay, they are quite what? Far apart. Now what happens, what interactions takes place now? You will see that what? The electrons of hydrogen A and electrons of hydrogen B, what they will do? They will repel each other, isn't it? Now the nucleus of hydrogen A and nucleus of hydrogen B, what they will do? They will repel each other, but yes, the nucleus, what is present in the nucleus? The protons, okay? So here the nucleus of hydrogen A and electrons of hydrogen B, what there will be? There will be attraction, isn't it? Charges are different, positive and negative. Like that, electrons of hydrogen A and the protons present in the nucleus of hydrogen B, there will be again what? Attraction. So here we are seeing two forces are acting, that is the attractive forces and the repulsive forces. Now, and this has been done experimentally, and here experimentally it has been seen, what it has been seen? The attractive forces are more, the magnitude of attractive forces are more than the magnitude of repulsive forces. Okay, and as the result, what will happen? The bond will take place, because here if the attractive force is more, what will happen? The bond formation will take place, because if repulsive force is more, the bond formation will not take place. That let us study with this. Here the energy is less, okay, and 435.8 kilojoule of energy is what? Being released out. Actually what happened here? Overlapping has taken place, okay, and as the result, now it has attained some stability and some energy is being released out. But after that we see what? Again the energy has started increasing. Okay, so if the potential energy is less, energy will also be less, and the molecule will become, or the atoms will become, here forming molecule, it will become stable in nature. Okay, so what did we understand from here? Here actually hydrogen, if we want to break the hydrogen molecule, if we want to break this, okay, we require 435.8 kilojoule, okay, per mole of energy, okay, to get hydrogen atom and hydrogen atom. But yes, if we want to form the molecule, yes, this hydrogen will combine with this hydrogen and release out what, how much energy? 435.8 kilojoule per mole. Okay, so here the concept of bond enthalpy comes. So bond enthalpy is what? Breaking the hydrogen molecules into hydrogen atoms, or breaking a molecule into the constituent atoms. Okay, so when we are breaking, what we are saying? Here the energy is required, and this energy which is required to break a molecule is known as what? Bond enthalpy. Now, let us study about overlapping of atomic orbitals. Okay, here overlap. Okay, overlap, you can see it is of plus phase or sign, minus phase or sign, or zero phase. Okay, or you can say zero just. Okay, this overlap is what? Due to what? Direction of the orientation of electrons. Okay, here due to this also we'll be seeing how the overlap is taking place. Okay, if it is plus, okay, positive phase, or if it is in positive in phase or in sign, okay, you'll see that here this is the p orbital, dumbbell shape, we have studied in the second chapter of atomic structure. Okay, here you are seeing what? The plus lobe and the plus lobe are overlapping. So this is positive in phase. Okay, when we are talking about negative out phase, okay, when it is negative phase or sign, you'll see that one lobe is what? Plus and another is minus, and they are overlapping. So this we say negative out phase, and when it is positive we say it is in phase. Okay, now, so what is now there? This here zero overlap. Okay, zero overlap is what? It is the out of the phase due to what? The different orientation direction of the the lobes or the orbitals, we can say. Okay, their approach is what? Is different, and as the result it is not proper, I will say. Okay, like you can see here px, okay, positive, negative down, above the plane positive, below the plane negative, and this is what? Spherical in shape, so it is what? S orbital. You can see here overlapping is taking place, but not to a proper extent. Here orientation is not proper in direction of approach of forming the, or of the overlapping the orbital. Okay, so, and next example you can see of px and py, you can see what? Both the lobes is positive sign above the plane and negative sign below the plane. Naturally what will happen here? Also overlapping can't take place due to the orientation of the electron. So here approach is not proper, and as the result the overlapping will not take place, and there we say what? It is zero overlap, because overlapping has not taken place due to the orientation of the electrons, because here the electrons are not oriented in a proper direction, so that there can be a proper approach of forming a what? Overlap. Now let us study this overlapping of atomic orbital with an example. Okay, I have taken the example of methane. Okay, central atom here is carbon. Okay, and these are surrounding what? Carbon. You know that. Okay, now how this happens? Central atom we will be taking, how this hydrogen is combining with this carbon will be seen. See the orbitals. Okay, we are seeing what? What is the atomic number of carbon? It is 6, isn't it? So it becomes what? 2 and 4, or you can write 1s2 and 2s2 and 2p2. Okay, this all you know. So this is in the ground state. 2s2, 1s2, 2s2, okay, 2px, 2py, 1, 1. Okay, this right now is empty, isn't it? Now what happens? We have studied that when the atoms are combining, what is happening? Energy is being released out. So some extra energy it is having right now. isn't it? So because of that extra energy, what will happen? This electron will be excited and it will be occupying this 2p z orbital. And so now in the excited form it is, you can see this s, 1s and 3p orbitals are participating. So when we will be arranging it, so s has got spherical shape, spherical, okay. P, it has got what? Dumbbell shape, made in this manner, okay. So p x, p y, p z, okay. What will happen in this? Here hydrogen, 4 hydrogen is there. So one will combine with this, one will combine with this, one will combine with this, and all will be at what? At 90 degree. Okay, these three. But still one hydrogen is left. It can combine with S anywhere, isn't it? Because S is what? Spherical in shape. So what happens when it combines? They join, anywhere it is joined, and when it is joined anywhere, okay, so what we are getting, 90 degree we are getting, but when we take it out, we see what? It is 109.5 degrees. So this 109.5 degree is contradicting 90 degree, isn't it? So because from here the theory of what? Hybridization starts, which we will be studying in the next video. So good day, take care.